Okay, so good morning, ladies and gentlemen. And it's really my great pleasure to be here to meet some old friends, also some new friends, and share some stories about what happened in China for the district heating systems. Okay, so sorry, I don't know which one. Yes. Could you show me which one is working?
No, it's working. It changed.
Oh yeah, it's working. Okay. So I think like many other countries, China also, we have many reasons to pursue more sustainable energy systems. So you can see that right now, if you're looking on the development of China for the economic and for everything, we still need more and more energies in the future. So how to pursue this, the energy demand growth and avoid these energy resources and the security issues becomes the first priority. And also, second part, I think some of you already visit China, you will find out that you're already facing some air quality issues, especially in the winter time, the smog. So here's some pictures looking here in Beijing. That's quite popular right now happening in China in a lot of cities. And also, we already know that China, we're already participating for the Paris protocols. So we're talking about global warmings and also looking on the future for this, how we could reach for the 2 degrees or 1 degree scenario. So that is also the challenge in the future we're talking about. So what's going to happen for the energy systems in China. So, yeah. So before I do that, actually I'd like to share you some general information, some statistics data about what's really happening right now in China. So you can see this chart is in the 2018. So the whole energy consumption with the whole nation. So some points I'd like to show here. You can see first number is over here. We still have nearly 60% of the energy which are coming from the coal. So this is the first I would like to mention for that part. And also if you're looking on the trend, actually still growing, but not as fast as before. So for example, last year we only reached for 3% of increasing comparing with our economic development. I was thinking, yeah, that's really low down a little bit compared to before. And also we'll find out that actually most of this energy increasing this consumption part will be these parts, which means the renewable energy. Okay, so the coal actually they're not increasing too much, but the renewable energy parts keep increasing. And then we're looking for the supply side. So we'll find out that in 2018, we have nearly 21% of the total energy which are imports. So including coal, crude oil, gas. So within this part specifically, I want to say that around 71% of the oil is imported from actually for China, and 43% of the natural gas is imported. So we look on this situation, definitely we're thinking about what's going to happen in the future if we're still requiring for more energy, and so how we could solve it. And also you can see 90% of the energy import are coming from the seaside. So within that part, we're also asking ourselves what we could do. So what about the energy resources in the future? So right now within this conference, a lot of people are talking about renewable energy. So that's why here I just list for these conditions. So what do we have in China? So previously, actually, someone told me that, or some information. I remember we discussed with Professor Lund. We think about actually if you look on the average value per capita for the floor area or even for the resources, China and Denmark are quite similar with the number. But right now we can see that Denmark actually we're reaching for, they're talking about 50% of renewable energy and even in the future 100%. But what's happening in China, what we could do? So over here, I just want to show you, this is some information here. Solar energy, hydropower, and the biomass materials. So the different color actually means that's the source's location. So over here, I would like to draw you one very important line in China. This is also quite popular in China. We call this Hu Huanyong line. Hu Huanyong is the name of a Chinese person who is really doing a lot of research for this kind of issues. So with this line, we'll find out some very interesting findings that in the east part of the line, you can see most of the cities in the east part. So 80% of the population in China were located on the east side. But if you look on the renewable resources, you can see more than 80% of the renewable resources were located on the west side. Okay, so with this distance, thousands of kilometers, because China is really a large country. So here I just list the solar, hydro, and the biomass is a bit different because in China, most of the biomass is coming from the straw, from the agriculture. So that's why it's here. It's listed mainly on the north and the middle part of China. Okay. So that's the match with the supply and the demand side. But if you look at on the solar and the hydro, later that another picture shows the wind power. It's almost the same situation as what's happening for the solar and the hydro powers. So that's the situation right now. We're talking about renewable energy in China. We're not talking about using renewable energy for heating, because normally heating it needs to match the supply and demand to the same location. But since it's so long distance, so over here you can see that only 1% of the renewable energy we're using for heating. It's mainly the biomass material. Okay, and for the rest part of the renewable energy, most of them due to this long distance, this separated from the supply side and demand side, that we're mainly using for electricity. Okay, so that is the reason over here you can see for the current situation, if you go on the supply side, this is for the installed wind power, solar power, and hydropower, and here is the nuclear power. So you can see it's increasing really fast. So, and if not only on the total number, comparing with present, you'll find out that for the wind power, we're 87% within the past 6 years, and the ranking already number first in the 2012. So happening for the solar and the hydropower. Hydropower is not increasing so fast, but still you can see that it's fully used, especially within the southwest part of China. Okay. Nuclear is still under discussing. Yeah. And also that's why you can see that comparing with the heating, within the electric parts, we already have nearly 30% of the electricity coming from the renewable energy. So nearly 20% come from the hydro, another 10% coming from the wind power and the solar energy. Okay, so this is the situation right now for the energy systems. And one more thing I would like to say was why reason I put the wind power over here, because I want to make a comparing work with the coal-fired power plants distribution. So you can see these pictures here. Most of the wind power, they're on the north side of China, which are quite matched, with the distribution for what's happening with coal-fired power plants. Yeah, because most of the coal plants, mines is in the northern parts. They're on the northern parts. So what's happening right now, you can see that in the northern part we need heating at the same time. So something happening that in the normal time, this coal-fired power plant becomes quite good resources could mix the balance or the regulations to match with these wind powers. So they're doing like this in the summertime. But what's happening in the winter time, because most of these coal-fired power plants working for heating, and they're just due to the current situations, they are just running these power plants according to the heat demands. So their lack of the regulation with the electricity sides. So what's happening? 80% of the wind curtailment was happening in the northern part of China, and it's happening in the winter time. So what's going to do? So what we could do with our energy systems, combining together with conventional, the coal fires or gas-fired power plants together with some renewable energy resources. That's what we're going to discuss in the future. So that's why if you look at energy flow in China, let's take an example for the electricity powers. You'll find that most of them go from the west to the east, from the north to the south. So in our 13th five-year planning, we already built around 6 at high voltage, these cables, coming from the north to the south, the west to the east. Okay. But however, if you're looking on that, because the renewable energy, especially for the wind power, are not so stable, and also for the demand side, so it's not quite matching. Even we built for these channels, we make this distribution, you will find out they're not fully efficient using. According to the last year, all these cables are running with around, if compared with the full capacity, they're only 5,000 hours, compared with more than 8,700. So only 50% of efficiency to use cables. So that's why how we could, manage this high efficient transportation from the energy flow. That's also need to be considered. That's also happening for this is coal. They're going from the same way, oil from the same way, and also the power and also the natural gas. You can see that all of them are coming from long distance distribution, from the west, north to the east and the south parts. Okay. So, let's talking about the district heating. So here are some backgrounds about some statistics again. So normally in China, we're not have district heating or heating everywhere. So only in the northern parts. You can see the several cold and the cold area with this area. So according to the last year, we find out that we have a total floor area around 13 billion square meters. Good part is that 85% of all this area were connected with our district heating systems. So that is really quite big achievements in China compared with some other countries. Of course, it still consumes really a lot of energy. 25% of the total in the building sector, and within the building sector, we have another 25% of the total energy consumptions, and keep increasing. You can see that. So, the advantage part of these sets. Right now, we have the world's largest district heating systems. So, if you're looking on the number over here, we really have a lot of long-distance piping network. But however, even worse with the total energy part, 90% of this energy will come from the coal. So what we could do to achieve some cleaner energy systems, especially for the district heating, that's also becomes a priority that we're thinking about with our energy systems. Here's some more data which we're trying to prove for previously. Over here you can see that 48% come from the coal-fired CHP, 33% come from the direct coal-fired boilers, and the red part will be the some biomass, industry excess heat, and also some geothermal and so on. Yeah, so this is going to be, the main concerning in the future. We're talking about how we could replace for this 30% of the directly coal-fired boilers. Okay. And also this part we show that this is the PM 2.5 concentrations for the past 5 years in Beijing, the capital area. You'll find out actually it's always increasing in the winter time due to I think some part due to the climate conditions, but also mainly due to we consume more energy in the winter time because we only heat our buildings in the winter time. So you can see always a peak. But of course, you will find out actually the situation becomes much better for the past 2 years because we already launched for these clean heating programs. So we're thinking about how we could do better with our district heating systems. So recently, actually, if you're looking on our policies, there's already something about how we could replace the coal to the gas. So do we think about the gas as the option in the future, how we could achieve cleaner energy systems? Here we'd like to show some data over here. So you can see that in 2016, this is total consumption for the gas, around 6% of the share. But in 2018, it's already reached to around 10% of the share. And 71 billion from the import, around 34, but in 2018, we already reached to around 120, and the share of the import is 45%. So we already did some briefly calculation. So if we could replace this 33% of this direct coal-fired boilers to the gas boilers, we're going to import another 300 billion of the gas to China, which already go to nearly 40% of the total gas amounts on the market for the whole year. So which means in the future, if something happening like this, so half of the gas which are on the market are going to import to China. So definitely that's going to be really a threat for the security issues and also for the markets, So that's why definitely we believe that that's not going to be happening in the future. So how could we using the gas? So it's sufficient using the gas also becomes optional. We're thinking about in the future. So within that parts, I think right now in China, where we really think the district heating or the clean heating becomes extremely important. So we're talking about this approach, the roadmap, China Clean Heating 2025. We're also talking about 2035. So like Professor here, a lot of researchers in Europe are talking about the heat roadmap, what's going to happen in China. But what's going to happen in Europe. Here we're also talking about in China. So according to previously, the introduction about the situations, the resources, what have, and the demand side, we believe that this is the 5 key solutions or the problems we're going to face and we could solve for our clean heating roadmap. The first one is the surplus heat applications. Over here, you can see that in China, previous I mentioned, we have most of our power plants is located in the northern part. And also we still have 50%, half of these power plants that they're using for electricity only. So we did some detailed investigations for more than 500, 200, the small towns, the small cities, talking about what they have within that area. So you can see this is the distributions about the coal-fired power plant. So what's happening if you just switch all these, these power plants to the CHP and using this condensing heat to heat our buildings? So actually, already can have really a lot of excess heat. The second part, we see that China is still the industrial countries. So more than 60% of the energy we're consuming with the industry producing. So according to all this data, we just find out nearly 30 to 50% of this industry's energy consumption comes with low-grade waste heat or with surplus heat, which you mentioned to the outside. So according to all this detailed calculation, we believe that also this industry surplus heat could play a very important role in the future. So here is some real data we're talking about CHP excess heat, industry surplus heat, and the biomass material, which in the northeast part, and also the waste, which about the sewage waters, and also the waste in the city. And also we're matching with the demand side. We can see that actually we do have enough, the cleaner heating resources which could fulfill with the requirement about current situation in the north part of China. So of course, the number is much bigger, but we need to take about the way and also the distribution and so on. So for example, over here, you can see, this is a map, actually it's nearby Beijing area. So the different nodes, according to you can see the different industry surplus heats also for these power plants. But actually you can see the distribution, they're not so evenly distributed everywhere. Okay, so some cities, they have enough, really quite a lot of the surplus heat, but some cities are not, they don't have at all. But if we take this 200 kilometers matching with the supply side and the demand side, actually we'll find out they could match very well. So that's why actually we're talking about in order to match with the supply side and demand side due to this uneven distribution in the geographic way, what we could do that we build this long distance piping network. So between the cities, not just inside between the cities, with a distance around 100 kilometers. So that already can give very good balance within what we already achieved, what we have, and matching with the demand side. So that's why we're talking about in the future what's going to happen with our district heating system network. So this is a conventional one, so we have it. But over here, we also have this long-distance distribution network, which are between the cities. So unlike over here, I can see, I think Henrik already mentioned that fourth generation district heating, we're talking about this low temperature district heating inside cities. We're also talking about this low temperature district heating, but mainly concerning about how we could reduce the temperature for the return water. We're trying to achieve the bigger, the temperature difference, so we could make this long distance distribution network to be economically acceptable. Okay. Already right now you can see in a lot of big cities in northern parts, we already built this kind of the long distance distribution network. So which supply temperature around 100, but return we could go to lower than 26 degrees. So that is actually the one way we think a little bit different, but actually I was thinking that also quite similar. We're talking about this statistics. And also for the technical solutions for how we could achieve this low temperature district heating systems, we'll find out actually, for the conventional way, maybe it's 50 and 40, but what if we're using the supply water temperature as the driving forces, using some heat pump, or even for some electric heat pumps could reduce the water temperature to 25, even to 20, so that we could solve the problems and trying to make it better, more efficient for our distribution systems. And also, we're talking about the integration of the energy systems, but we know that the heating electricity and even for the gas, actually they're combined together, and also so the system also could be integrated. So there's actually, I think there's similar things about how we could integrate those power grids, heat network, and the gas network together. We're concerning about this high efficiency, the power to heat, and also the gas to heat and the gas to power, and using a lot of different kind of ways for storage, trying to balance which is this integration of the systems. Okay, so that's going to happen in the future when I'm talking about these integrated systems. And over here, the main part I'm going to talk about that is how we are treating within the gas. Yeah, because still you can see that when we're talking about renewable energy, it's not so stable. But wind power and the solar, and so we need some conventional energy systems trying to make this peak load regulations a balance. So storage could be a very good way, but also we think the gas could play a very important role in the future. So that's why in our system we think about that we're going to use the gas as a peak load shavings for our distributed systems and also for the electricity systems. So only for the peak load. And of course with that way that could be very high efficient usage and much less energy, gas could be consumed. So due to the time limits, so I'm just trying to stop here and some recommendations. And we can see that the systems, energy systems in the cities becomes more complex than before, especially we introduce more renewable energy systems inside. So that's why we believe that the policy and the planning becomes extremely important in the future. Yeah, we need to know that's what we have and what we need and how we could reduce for the demand sides and how we could match with the supply side with demand sides. Okay. And also we just find that recently we look on this policy in the marketing, especially for the pricing issues becomes extremely important. Because right now if you're looking on that, the Chinese situation, this low price coal, actually there becomes a barrier for us to use put more renewable energy within our energy systems. And the demand sides, energy efficiency always becomes extremely important. So reducing the energy consumption or reducing energy demand is always the first priority in the future. We're talking about our energy systems. And supply side, I think it's always important that we're looking on the, according to the what we really have. So it really case by case or country by country. So the situation could be really quite different. So that's why we need to have this, investigations about what we really have and trying to match with the supply side and demand side, and with some new technologies and also the political policy support. Okay, I think that's all for my presentations. Thank you very much.